Okay, so this is our video for the fan cart speeding up in the negative direction.
Okay, so for when we graph the position of the motion of this fan cart in the first graph right here, we got a curve going down, and basically what that means is that originally, well, by looking at the slopes of this, you can tell that the fan cart was speeding up because the slope increases as you move to the right, and it is moving in the negative direction because this is graphed where the positions are negative. And then what happened was when we wanted to get the formula for the equation of the position time graph, we couldn't because it was a curve. So if you look at our second graph, we linearized it and we graphed position and time squared. So what we got was the formula position equals negative 2 inches for every second squared times time squared minus 2.4 inches. And basically what that means is, well, for the intercept, when we were at time 0, we started at basically position of negative 2.4 inches. And what the slope means is that this is basically how fast we were traveling, and because it is a curve, it's written as negative 2 over seconds squared. It's not just seconds.
And you know it's inches over second squared times time squared because when you solve that out, the second squared and time squared, they cancel out to give you just inches squared, and that's position. So that's how you know it's inches over second squared. Now to look down at this bottom graph, which is our velocity versus time graph, you see that it has a negative slope because it's going down, but you know that it's for this one and that it's slowing down or speeding up in a negative direction because the values, the magnitudes of the velocities get bigger over time, and they just, they're more negative numbers, so they're smaller. So they're increasing magnitude, but they're all negative. So, like I said, the slope of this is negative. So that means the acceleration is negative, and the slope of the line is negative 2 point. We'll just say negative 2 inches over second squared. So therefore, the acceleration is constant at negative 2 inches over second squared. So the equation we got was velocity equals negative 2 inches over seconds divided by seconds times time minus 1.57 inches over seconds. So what that means is that every second you are decreasing in velocity negative 2, and at time 0 your initial velocity was negative 1.57 inches over seconds. Now to find displacement, you take the area of this velocity graph. So I'm going to highlight it like so.
You don't have to highlight it, just click. It's okay. Just click.
And then click integral, and it says that the integral is negative 27.23, so I'll say negative 27.25. So it says that the displacement is negative 27.25 inches over. So the displacement is how far the object traveled position-wise. So it's saying it went back 27.25 inches, and it started based off our first equation at 2.4 inches, or negative 2.4. So then the final position would be around 30 or negative 30 inches.